going to discuss the first chapter of your organic chemistry, that is haloalkanes and haloarenes. So in this chapter we are going to discuss the classification, nature of carbon and halogen bonds, the physical properties, chemical reactions and polyhalogen compounds. So first we will see what are haloalkanes. So haloalkane, aliphatic hydrocarbons are called as haloalkanes. So now let us see how we are going to obtain these haloalkanes. So they are obtained by the replacement of one halogen atom from a alkyl group or more halogen atoms from a alkyl group. We are going to get the haloalkanes. Now we'll just see a simple example here. So if I take a methane here, so by removing one hydrogen atom and by addition of a halogen, we are going to get a haloalkane. So the replacement of a halogen atom in a hydrocarbon, we are going to get the haloalkanes. So now we will see where all these haloalkanes and haloarenes are used. So these haloalkanes and haloarenes have wide range of application in medicines, industries as well as in our day-to-day life. So these derivatives, they are used to dissolve the non-polar solvents. They are used to dissolve non-polar solvents. As these non-polar solvents do not get dissolved easily, these derivatives of haloalkanes and haloarenes are used to dissolve these non-polar solvents. And they are used as a starting material in the synthesis of many organic compounds. So they are used as starting material in the synthesis of many organic compounds because these halogens are very reactive and they trigger the reactions. So another one, the naturally occurring haloalkane, that is chlorine containing haloalkane, chloramphenicol, which is obtained from the soil microorganism and it is used for the treatment of the typhoid fever, and this is an antibiotic and used in the treatment of a typhoid fever. And our body produces halogen containing, that is iodine containing hormone thyroxine. So deficiency of this thyroxine causes goiter. Next, a halothane, or it is also called as a fluorothane, which is used as an anesthetic drug during the surgery. Here it is used to make a patient unconscious during the surgery, that is halothane, or it is a fluorothane here. It is used in the anesthetic drug in the surgery to make a patient unconscious. So these are few examples where the halogens are used in they are used in a medicinal purpose in industries as well as in our day-to-day life. So next we will discuss the classification of these haloalkanes. So classification of haloalkanes. So first we will see the classification based on the number of halogen atoms present. So based on the number of halogen atoms present, based on number of halogen atoms present, the haloalkanes, they are categorized into monohaloalkanes, dihaloalkanes and trihaloalkanes. So, depending upon the number of halogen atoms present, they are classified into monohaloalkanes, dihaloalkanes as well as trihaloalkanes. We'll see one by one. So first we'll see a monohaloalkanes. So these monohaloalkanes are obtained by replacement of an hydrogen atom in each molecule of an alkane by the halogen. We are going to get a monohaloalkane. The name itself suggests mono, a single. So it is obtained by the replacement of one hydrogen in each molecule of alkane by a halogen. If I have to take an example here, CH3Br. Here you can see only a single halogen atom is there, methyl bromide. So monohaloalkanes, only a single halogen atom is attached to the alkyl group. So again, these monohaloalkanes have been categorized into three types depending upon the halogen atom attached to the carbon, whether it is a primary carbon, secondary carbon or it is a tertiary carbon. So these monohaloalkanes again they are categorized into three types: primary alkyl halides, secondary alkyl halides, and we have tertiary alkyl halides. If a halogen atom is attached to the primary carbon, then we are going to call it as a primary alkyl halide. Here you can see the halogen atom is attached to the primary carbon here. So how will you come to know it is a primary carbon? So in this, the halogen is attached to the primary carbon where it has got two hydrogen atom and it is attached to a single carbon here. For example, if I take CH3CH2Cl ethyl chloride, where the halogen atom is attached to the primary alkyl halide. So it is called as a primary alkyl halide. Next we will move on to the secondary alkyl halide. So here the halogen is attached to the secondary carbon. halogen atom, that is bromine, is attached to the secondary carbon. This is having, it is linked to one hydrogen and two carbon atoms here. Next we will see a tertiary alkyl halide. So here the halogen is attached to the tertiary carbon here. So this is tertiary butyl iodide. Here you can see a halogen atom, that is iodine, is attached to the tertiary carbon atom. So this is the classification of the monohaloalkanes, where the halogen atom is whether it is attached to the primary carbon or secondary carbon or a tertiary carbon atom. So next we will move on to the dihaloalkanes. In dihaloalkanes, there is a replacement of two halogen atoms. So, there is a replacement of two halogen atoms in the alkyl group. For example, you can see here the two halogen atoms are attached to the alkyl group. So, it is these dihaloalkanes, two halogen groups are attached, and again these dihaloalkanes, they are categorized into geminal halides and the vicinal halides. Dihaloalkanes, they are categorized into geminal halides and vicinal halides. So, the word geminal is derived from a Latin word where gemini means twins, and these geminal halides, they are also called as alkalides. So, in geminal halides, the halogen atom is attached to the same carbon atom. For example, see here the two halogen atoms are attached to the same carbon atom. This type of the halogen atoms, we are going to call them as geminal dihalides. One dichloroethane. In the vicinal dihalides, this is also derived from a Latin word, the vicini. It means neighbor. So, the vicini, it means a neighbor. Here, the halogen atom is attached to the two adjacent carbon atoms. So, these are the types of the dihaloalkanes. They are geminal dihalides and the vicinal dihalides. Then, we will see the alkenes, we are going to call them as a polyhaloalkanes. If 3 halogen atoms are attached, then it is a trihaloalkane, tetrahaloalkane. Like that, we have more number of halogen atoms attached, we are going to call them as a polyhaloalkane. So, this is based on the number of halogen atoms attached to the alkyl group. Next, we will see the categorization or classification based on hybridization. This classification was based on the number of the halogen atoms present in the alkyl group. Now we will see the classification based on the hybridization. Based on the hybridization. Second one, based on hybridization. So based on hybridization, it is categorized into whether the halogen atom is attached to sp3 carbon atom or whether it is attached to sp2 hybridized carbon atom. Whether the halogen is present on the sp3 hybridized carbon atom or it is a sp2 hybridized carbon atom. So first we will see, based on hybridization, the halogen atom attached to sp3 hybridized carbon atom. So based on this, again this is classified into alkyl halides, allylic halides, and we have a benzylic halides. The alkyl halides we discussed in the monohaloalkanes, that is primary alkyl halide, secondary alkyl halide and a tertiary alkyl halide. Now we move on to the allylic halides. These allylic halides, they are the monohalogen derivatives of alkenes and cycloalkenes. Here the halogen atom is attached to the saturated carbon atom adjacent to the carbon containing double bond. So they are the monohalogen derivatives of alkenes and cycloalkenes, where the halogen atom is attached to the carbon atom adjacent to the carbon containing double bond. Allylic halides, they are the monohalogen derivatives of alkenes and cycloalkenes. So for example, I take for the allylic halides 3-chloro-propanene. So the chlorine is attached to the saturated carbon, where it is attached to the carbon containing the double bond. Such halogen atoms, we are going to call them as allylic halides. This is 3-chloro-1-ene, where the halogen atom is attached to the saturated carbon, which is attached to the carbon with the adjacent carbon, which is having the double bond, is a allylic halide. Another example of a cycloalkane, where the halogen is attached to the carbon, which is adjacent to the carbon containing the double bond. This is 3-chloro-cyclohexane. So they are the monohalogen derivatives of alkenes and the cycloalkenes. So the next one is the benzylic halides. So these benzylic halides, they are the monohalogen derivatives of the aromatic hydrocarbon, where the halogen atom is attached to the saturated carbon atom present adjacent to the aromatic ring. So the next one is the benzyl halides. So where the halogen atom, or they are the halogen derivatives of aromatic hydrocarbon, where the halogen atom is attached to the saturated carbon adjacent to the carbon present to the aromatic ring. For example, so the halogen atom is attached to the carbon adjacent to the aromatic ring. Chloro, methyl, benzene. So they are the halogen derivatives, the benzyl halides. They are the halogen derivatives of the aromatic hydrocarbon. So this is based on the hybridization, where the halogen atom is attached to sp3 hybridized carbon atom. Now we will see the classification based on where the halogen atom is attached to sp2 hybridized carbon atom. Where the halogen atom is attached to the sp2 hybridized carbon atom. So in sp2 hybridized carbon atom, the halogen is present on the unsaturated carbon atom. Hence, the carbon atom containing halogen contains a double bond here. So again, this we have two types, that is vinylic halides and the aryl halides. Again, these are categorized into vinylic halides and aryl halides. So first we will see the vinylic halides. Here the halogen atom is attached to the sp2 hybridized carbon. Vinylic halides. So here you can see the halogen atom is attached to sp2 hybridized carbon atom, which is having the carbon containing double bond here. So next is the aryl halides, where the halogen atom is directly attached to the aromatic ring. Where the halogen atom is directly attached to the aromatic ring. These type of the alkanes we are going to haloalkanes and haloarenes classification, where we have vinylic halides and aryl halides depending upon the halogen atom whether it is present on the carbon containing sp2 hybridized carbon atom. So today we discussed about the classification of the haloalkanes. Based on the number of the halogen atoms, we have monohaloalkane, dihaloalkane and a polyhaloalkane. Based on the hybridization, we have halogen attached to carbon containing sp3 hybridized carbon atom and the halogen attached to the sp2 hybridized carbon atom. So again, the monohaloalkanes, they are classified into primary alkyl halide, secondary alkyl halide and a tertiary alkyl halide depending upon whether the halogen atom is attached to a primary carbon, secondary carbon and a tertiary carbon. In dihaloalkanes, they have been classified into geminal halides and vicinal halides depending upon whether the halogen is attached to the same carbon atom or it is attached to the adjacent carbon